Hello, everyone. Welcome to the second episode in our podcast, Let's Talk Science. Today, I'll be interviewing the exceptionally talented Dr. Sara Port. Now, Dr. Sara Port is currently a NASA postdoctoral program fellow at the Glenn Research Center in Cleveland. She's also a newly appointed member of the VEXAG Steering Committee. Her work focuses on experimentally investigating surface-atmosphere interactions under simulated Venus conditions. And this data will offer insight into the chemical cycles transpiring on Venus and may unearth clues on the atmospheric and geological history of Venus. Now, Sara obtained her PhD in 2019 from the University of Arkansas. Her primary focus was to investigate the origin of the low emissivity anomaly observed on several highland regions on Venus, and she exposed various high dielectric minerals to simulated Venus conditions using the Venus simulation chamber located at the university. And while at the university, she became the president of the on-campus Astronomy and Planetary Science Club and the vice president of the Badminton Club. And during her graduate career, she has given 7 oral presentations in 3 different countries and has completed research abroad in Germany at the DLR and Japan at the University of Okayama. Well, thank you so much, Dr. Port, for being a part of this podcast. It's a pleasure to see you. How have you been?
Thank you. Thank you for the introduction. I'm doing pretty well. It's been a little rough as an experimentalist because I haven't really been able to do the experiments part, but I'm surviving. I'm looking forward to hopefully doing experiments soon.
Wow. And I must say you have quite an extensive resume of accomplishments and achievements as a scientist. So it's really spectacular to have you on this program. So thank you so much.
Thank you. Thank you. No, it's, I love doing this and I go out of my way to try to get involved in as many activities as I can because it's fun.
Yeah, for sure. And space is just one of those subjects that evokes very strong interests and emotions amongst very many scientists. And you're certainly one of them, I presume.
Yes. Been in love with planets my entire life, practically.
Yes. So I guess we could jump straight into the questions. And exactly a year ago today, there were major headlines all over the news about the potential for life existing on our twin planet, Venus. And this was primarily spearheaded by the detection of phosphine in its atmosphere. And then following this, there was really this mass enthusiasm amongst both scientists and just really curious individuals as scientific instruments attempted to unearth the mysteries hidden beneath the Venusian atmosphere. Do you think there is merit to the idea that life might exist there? And what does the detection of phosphine tell us?
Yeah, so those are very good questions. So regarding phosphine, there was a lot of excitement over the original detection a year ago, but there also have been a number of papers that have come out since that have stated that maybe it was not phosphine, maybe phosphine does not exist. I think that is something that definitely needs to be explored, whether it is there or not. So hopefully maybe a future mission could potentially answer more of those questions of if it exists or not. Regarding life on Venus, that has also been discussed heavily for the last number of years. And that's another one where we can't say for sure if it exists or if it doesn't. It might exist, it might not exist. And the only way to really tell is if we go there and to actually try to study the atmosphere and to see if there could potentially be microbes there.
Right. Okay. So what sorts of missions have we sent to Venus already that might provide the data necessary in order for us to figure out definitively whether or not there is life on Venus?
So past missions have not been looking for that at all whatsoever. So the last time that something really landed on the surface of Venus to look at the surface was the Vignetta 14. Which was 1984, I believe, by the USSR. So the USSR had the Vignetta program where they sent a slew of different Vignetta probes as well as orbiters to try to study the surface of Venus. And then we had NASA sent out Pioneer Venus as well as Magellan. And Pioneer had a balloon, and so it was able to study a little bit of the atmosphere, and Magellan was able to study the surface using radar. So they really did not have any strong evidence. They weren't looking for life. There wasn't any evidence there that said, oh, look, that could be potential for life. The newer missions maybe could potentially give some clues on it. They're also not directly designed to look for life, but they are designed to look at the atmosphere. Some of them are, not all of them, to look at the atmosphere. And maybe from there, we can try to see if maybe there is some clues for life. And there's been discussions for future missions that could potentially look for life, something that can float in the clouds, that can capture particles in the clouds and to kind of analyze those particles.
Wow. Okay, so it seems that Venus is not necessarily known for being the most friendly planet for life in the solar system. So what sort of chemical, atmospheric or geological variables were at play that sort of distinguish Venus from Earth?
Yeah, so Venus is very different from Earth, even though it is the same size, the radius very similar, but the surface is very, very hot. We're looking at about 460 degrees Celsius. It's hot enough for lead to melt at the surface. The pressure is 95 bars of pressure. What we feel here on Earth is 1 bar, so 95 times that. And then on top of that, a lot of noxious gases, mostly CO2 atmosphere. You also have some SO2. You also have HF, HCl. You have clouds of H2SO4. And it's it's not a very friendly place to live, let's say that. So that's one of the reasons why Venus is so exciting, is because it's so different. Why is it so different from Earth? And why is it so different from all these other terrestrial planets in our solar system?
Right. And I think Mercury is closer to the sun, yet its daytime temperatures, correct me if I'm wrong, are not as hot as, say, Venus. So what is the primary reason behind that?
Yeah, so Venus is hotter than Mercury, and the reason for that is that atmosphere. That atmosphere just absorbs that radiation and it distributes that across the entire planet. So the temperature difference between the sun-facing side and the other side, I believe, is very, very, if not the same temperature, very similar.
Wow. Okay. So it seems like on Venus there's like a substantial greenhouse gas effect that traps and warms up the planet to an extensive degree. So is that correct? Am I correct in my understanding?
Yes, that is correct.
Okay. All right. So Venus is, of course, very far away from the Earth, and millions have to be spent before we even send a mission to it, in the form of like a simple probe. So how is it that scientists conduct experiments to understand the surface atmospheric interactions in Venus?
So first, I just want to quickly comment that Venus is actually closer to Earth than Mars is to Earth. Mm-hmm. Which is something that people don't realize. And the reason that we just don't go to Venus is because it is a little bit more difficult. I can't actually comment on some of the, there's some research being done at Glenn to try to create landers that can survive, or the tech for landers to survive for long periods of time on Venus. So the way that most people, how we've been studying the surface of Venus is by using either ovens or pressure chambers. So we try to get to Venus temperatures at least, and then an oven will not have the pressures that you find on Venus. It'll be atmospheric pressure here. But the autoclaves, these pressure chambers, will try to get to the pressures of Venus. And then we fill it up with gases, both these apparatuses, with gases that are found on Venus. And then you can study, for example, mineralogy, which is what I study. So I put minerals in these ovens and these chambers for a long period of time to see how it changes over time. But you can do other studies as well. There have been people who have been trying to study atmosphere interactions, just the atmosphere itself. There's talks about people want to study even more in depth. So there's just like atmospheric chambers, cloud chambers. And then there's also research being done on materials, and if materials can survive the conditions on Venus. You know, if we send a lander, will the the lander itself survive? Will it react? What will happen?
Sure. So in those little chambers that you mentioned, are they able to replicate, say, the same pressures of 95 bars on Venus? Or is it just sort of the atmosphere that they are replicating?
They can represent the pressure. So if it's a autoclave, they do represent, they can get up to Venus pressures. The experiments that I was doing in graduate school, we were doing 92 bars in this little 500 milliliter cylinder.
Wow. Yeah. So it seems like you have the physical aspect of simulations. What sort of computer simulations do you guys use in order to understand Venus?
That's a very good question. So there have been a number of people trying to simulate the surface, but it is very difficult. And the reason it's very difficult is because we don't even know how the atmosphere very well, particularly in the lower atmosphere. There hasn't been enough data collected. And because of that, it becomes a little difficult, a little tricky to try to model the atmosphere. There's also debate that the atmosphere may not even be in equilibrium. So that means it's not, even if a lot of these models that they have, will model until everything's in equilibrium, which could not, it's possible that's not even the case. So researchers are looking into trying to incorporate kinetics to understand maybe the atmosphere change over time, but there's just so many compounds, so many different gases, so many gases that could exist that we don't even know about on Venus that make it a little tricky. So that's one of the things that researchers are trying to do right now. And that's one of the things that's very exciting about the Da Vinci mission, because Da Vinci will go through the atmosphere of Venus and collect data on the gases. And if we can at least get data on the trace gases and the abundance of gases, we could potentially be able to model Venus better.
Sure. So in order to, say, make these simulations, first we have to actually acquire the data, and that can be made possible through future missions that we're planning to Venus. So what are some of these missions that we're planning, and have they been formally named yet?
So there are 3 official missions that are going. Well, technically it's 4. So we have 2 from NASA, which is Veritas and Da Vinci. It was Da Vinci Plus. I heard that they've removed the plus, but it's either Da Vinci Plus or Plus. And then ESA, the European Space Agency, is launching Envision. And then the Indian Space Agency also said that they will have their own Venus mission. I haven't heard, unfortunately, too many updates recently, but hopefully everything is going well for that. And then the Russian Space Agency is also planning, it hasn't been approved yet, the Venera D mission, which actually there is a workshop, the Venera D workshop, coming up in November, which I'm part of the organizing committee for that. Just talking about science and what we would like to learn through Venera D if it's approved.
Wow. Okay, so that's like a plethora of different missions, and it seems all so exciting. And I think one common trait that that most of us, if not all of us, have as humans is this curiosity to figure out what is unknown. And so that's really what drives the bulk of all of these missions. It's to really understand what we don't know. We have a burning passion and desire to do that. As a scientist, what drives you to learn more about Venus?
I've just always been someone who loves learning more. As a child, my favorite channels were Science Channel, Animal Planet, History Channel, Discovery Channel. That's what I would watch all the time. I would read books on science. I would carry a periodic table in my backpack in elementary school. So I've always loved asking questions. I was always very curious. And so with Venus, it's just, I think it's such a fascinating planet. It's a planet that also has just, people have not been interested in, and it's been sad. I'm very excited that there are missions happening, but before these missions were announced, it was overlooked. Like I said, the last lander was 1984, Magellan was 89 and 95. And then we did have VEX, which was an ESA mission, which was an orbiter, as well as Akatsuki, which was a JAXA orbiter mission. But there wasn't much on the surface. They were both atmospheric missions. Last one was really Magellan that studied the surface. So I think it's sad that it's been overlooked, and it's just a fascinating planet. There's so much to learn. And by also learning about Venus, we better understand planetary formation in our solar system, but also in other exosolar systems.
Right. And, a lot of people have concerns about the real tangible benefits of exploring planets like Venus and space exploration in general. So, as a scientist who spends a majority of your career studying planets like Venus and space exploration in general, how do you comment on those questions?
So, I mentioned earlier that NASA Glenn, where I'm working at, is heavily involved in trying to develop the technology to land, or at least the technology for a lander to exist on the surface of Venus for long periods of time. So that tech actually does exist. There have been electronics, and I'm not an engineer, so electronics and different materials that have been tested within a Venus simulation chamber for up to 60 days, and it works. And there's also a long-lived, so my postdoc advisor, Tibor Kremik, he is the PI for this little lander. It's not really a lander, but it's called LISSE, LLISSE, LISSE. And basically it can take data for, it's a concept that can take data for temperature and pressure for long periods of time, maybe 60 days, and that can be added to future landers. So that kind of technology does exist, and there has been people are still continuing to push that 60-day limit. And then on top of that, JPL has been looking at balloons and trying to find the right type of balloon that can move through the atmosphere of Venus for long periods of time and take data on the atmosphere, maybe potentially even the surface. So this tech does exist, and I'm excited that we're finally going to go back to Venus, and hopefully people find out about all this tech that people are studying, and so they can be incorporated into future Venus missions, and we can get even more data.
Wow, that's really exciting. Just thinking about all these new missions that we're potentially going to spearhead to send to other planets is just incredibly fascinating. So it must be really interesting for you as a scientist to be at really the foundation, developing groundwork for all these missions. Yeah. So, the origin of life in the cosmos is complex to understand, and not many people are gifted with the requisite levels of curiosity to learn more about the world. So, as we send future missions to the moons of other planets, like Jupiter's Europa, which is suspected to have an entire ocean tucked underneath its ice crust. Um, do you think life exists there? And could humans one day set up bases and colonies there? And how will our curiosity play a role?
Yeah, so I think those are very good questions. I think it's possible. Like I said with Venus too, it's possible. We can't say yes or no until we actually get the data. And that's what drives us, is the data. What does the data say? So it may be very possible, and that would be really exciting if icy moons such as Enceladus and Europa do have life in the ocean. Will we be able to get there one day? That's a good question. I don't really know. I know one of the problems with those inner moons of Jupiter is that they're within Jupiter's radiation fields, which makes it potentially dangerous to land there. That's actually one of the reasons why the China Space Agency, they haven't chosen it yet. They haven't decided, but they are considering a mission, not a manned mission, but a mission to Callisto, because Callisto is actually outside of Jupiter's radiation belt, and maybe even a lander there. So that would be really
Right.
cool. So, I mean, we'll see as we start to try to get humans back on the moon and then onto Mars. Who knows what we can do after that, where we can go as we advance that technology.
Yeah. And so what do you think about all these Mars missions that that people are considering right now, like Elon Musk, Jeff Bezos, and a couple of other tech billionaires all investing their assets for the future of setting colonies and bases on Mars? Do you think it's a goal that might be realized within our own lifetimes of terraforming Mars, setting up colonies there?
Terraforming Mars, no, not within our lifetimes. Setting up colonies, maybe, maybe. Depends. How old am I? How long am I going to live for? But maybe. I do think it's a good idea to try. I think Elon Musk and Jeff Bezos to try to get to Mars will be very beneficial, because not only is it useful to kind of spread out to go, well, it's very cool. Let me be honest, I think it's really cool if we can go to Mars. But when you're doing these things and you're pushing the limits of technology, you end up developing new technology that can be beneficial to everyone. I mean, that's what we found when we've sent astronauts into space, into the ISS. A lot of the tech we use on a day-to-day basis was actually developed by NASA
Right.
for the
Spin-off
astronauts in the
technology.
first place. Yeah.
Mhm.
So I think it's great. And I think, they have the money to do this. Sometimes there are limits and, regulations within the federal government. But when it comes to the private industry, they're able to really push that limit. And so I think that they are helping to drive space exploration.
Of course. And like you said, there's so many new technologies that sort of find their way into our own lives when NASA works on very hard and ambitious goals. And so that's one of the reasons why space exploration is really beneficial to life here on Earth. It's not just a matter of pumping money on a rocket and burning it in the atmosphere. That's not what space exploration is about. It's about expanding our curiosity, learning more about the universe and our place in it, and B, making improvements on life here on Earth.
Yes,
Yeah.
I agree.
Yeah. So, what advice do you have for students that are interested in pursuing careers in astronomy and physics? What should they start doing in high school or even introductory college level classes? What clubs, extracurricular activities, or programs should they participate in?
Yeah, no, that is a great question. It's something that I frequently talk to high schoolers and undergraduate students about this, because it's something that you don't really understand until you're involved in it. So for example, myself, I've always loved planets. I want to study planets, and I loved astronomy in general. I had a telescope. I love stars and so forth. I didn't realize going into undergrad that planetary science was different than astronomy. And so I have a degree in astronomy, but I also studied geology and chemistry and biology and so forth once I realized that it is different. So one of the things that I would recommend is in college, in high school, you can try to read books on different planets and sciences and so forth. But when you're in college, you should definitely try to take classes that aren't part of your major. And because that could help you figure out what you like and what you don't like. You may realize that you like a different field of science completely and you had no idea. I had a friend and she was also getting a degree in astronomy. Her first semester, she did very poorly and she was devastated. And then she switched to geology and she is phenomenal. I mean, she's a very brilliant person. So she realized that she was really good at geology. And from there, she started to study Mars and she became a planetary scientist. So that's the advice I have, is really take other classes that aren't your major, talk to people within that department, to professors, graduate students, see what their advice is. And yeah, just keep your options open.
Right. Yeah. Yeah, that's really good advice for anyone that's really interested in astronomy and physics. And I'm sure that if we leverage what you said here today, and we really incorporate all the advice that you sent in our own lives, then we'll take humanity to a new level. Well, anyways, Dr. Port, thank you so much for being a part of this video. I really enjoyed speaking with you, and I feel that I might just be developing a major interest in Venus and planetary science after hearing from you. Once again, thank you, and I look forward to talking to you again soon.
Thank you so much for having me on here, and I'm really happy that you are now interested in planetary science and Venus. I did my job.
Sure. Thank you so much. Appreciate it.